Chapter 4, Polynomial Functions. 4.1, Graphing Polynomial Functions, which is on page 158 to 161 in your textbook. A polynomial is an expression of algebraic terms. Polynomials often consist of the sum of several terms that contain different powers of the same variables. Okay, so a polynomial function can be written in function form. I'm not going to really explain this other than this. A sub n, that term out in front, is called our lead coefficient. The first degree with the lead coefficient, n is the degree, the exponent that it's at. Now, it will always go in descending order. For instance, like you'll see n and then n minus 1 all the way to no n, like 0, exponent being 1 and then 0. So the exponents would go like x to the fourth power plus x to the third power plus x to the second power plus 2x to the first power plus 5, right? So, and then that would be x to the 0 power, which is 1, which actually gives you a constant. So you go in descending order, you go down in degrees. A sub 0 right there, again, has x to the 0 power, which would be 1, which you don't have the x anymore. Alright, it's called a constant. Exponents must be written in whole numbers, 0, 1, 2, 3, 4, 5, and so forth. Coefficients must be real numbers, no imaginary numbers. Okay, so I'm going to go ahead and explain this common polynomial functions. We have different types, which we name, and if we have a degree of 0, it's called a constant, and it looks just like this, negative 14. If I have a degree of 1, it's called a linear function, a straight line. Looks like this, 5x minus 7, right? Which we graph, it's a straight line. Degree of 2, quadratic, right? Which we've been working on, something like this, 2x squared plus x minus 9, right? That power of 2 tells us it's a quadratic. 3 is called cubic, something like this. X cubed minus x squared plus 3x, power 3, cubic function. And power 4 is called quartic, and it looks like this, for example, x to the fourth power plus 2x minus 1. Okay? Alright, so concept 1 is really identifying the polynomial functions, and it states this, alright? It says, determine whether each function is a polynomial function. If so, write in standard form, state the degree, type, and lead coefficient. Alright, and I am just going to walk you through these without writing them here. Okay, so here we go. This one, f of x equals 2x cubed plus 5x plus 8. Alright. First of all, is it written in standard form? Yes, because it goes in descending order. Exponents go 3, 1, 0. What's the degree? Power of 3, right? 3 is my degree. What type is that? It's called a cubic function. And then what's my lead coefficient? Well, my lead term right there, the coefficient is 2. B, I have g of x equals negative 0.8x cubed plus square root of 2 times x to the fourth power minus 12. Alright, this one is not in standard form because the exponents go 3, 4, 0. So it must go 4, 3, 0. So here we go. I change it. G of x equals the square root of 2 times x to the fourth power minus 0.8x cubed minus 12. What's my degree? 4. What do we call that? Type is quartic. What's my lead coefficient? The square root of 2. C. Alright, I look here. What should you notice? Well, I have the x to the negative 1 power. As it said, we cannot have negatives, only positive whole numbers. Right, so that's not a polynomial. 4. I look right there. I have 3 to the x power. That is not okay, right? Must be a whole number, therefore that's not a polynomial. Alright, if you could pause and go ahead and try 2, 3, and 4 real quick. I'm going to show the answers right now. So again, please pause. Alright, here we go. Here are your answers for 2, 3, and 4. Check them out. Correct them if you need. Pause if you need more time. I'm going to keep on going. Alright, flipping it up. Here we go. The next part says to evaluate a polynomial function. Alright, well, when we evaluate a polynomial function, it says evaluate f of x equals 2x to the 4th power minus 8x squared plus 5x minus 7 when x equals 3. All you're doing is substituting 3 for x. So you plug in 3 and then simplify, right? 2 times 3 to the 4th power minus 8 times 3 squared plus 5 times 3 minus 7 gives us 162 minus 72 plus 15 minus 7, which simplifies to f of 3 is 98. Alright, you go ahead and try. We've done this so much, I'm not taking a ton of time with this. Evaluate f of x equals negative 2 x to the 4th power plus 6x cubed minus 3x plus 11 when x equals 4. Pause, give that a try. I am going to go ahead and show the answers now. Okay, your answer, f of 4 is negative 129. Scoot that up here a little bit. Take an extra time to take a look if you like. I'm going to keep on rolling. So, end behavior. Now this is brand new. This is probably where we get challenging. And we're going to graph with this end behavior. So, that's why we need it. The behavior of a function's graph as x approaches positive or negative infinity. End behavior. For polynomial functions, the end behavior is determined by the degree, the function's degree, and the sign of the lead coefficient. The sign of the lead coefficient. Those are the keys right there. Alright, we have 4 end behaviors. Alright, we have odds. Odds are going to either start and end in opposite directions. So if I have an odd positive, it starts on the bottom and it goes up, just like a linear equation, right? If I have a positive odd, it's going to go up. If I have a odd and it's negative, it's going to start on the top and it's going to go down like a negative slope and finish on the bottom right. What I want you to remember, odds start and finish in opposite directions. Evens. Evens start and finish in the same direction. Okay? So, even positive is going to start and finish going up. Even negative is going to start and finish going down. Now, there's more to this, but that is the main gist of it. Okay? So that's really what I want you to focus on. Now I'm going to kind of explain this a little farther into detail, and I'm going to walk you through on the problems. But this is how we read it. F of x approaches negative infinity as x approaches negative infinity, and f of x approaches positive infinity as x approaches positive infinity. What does that really mean? Well, f of x is really the y going up or down. So if it says negative infinity for f of x, that really means it's going down. If it says positive infinity for f of x, that really means it's going up. Alright, x is your horizontal, right, x-axis. So if it says x approaches negative infinity, that really means it's going left. And if x approaches positive infinity, that means it goes to the right. Okay, I'm going to walk you through step by step. This page right here, though, you may want to come back to and continue to check as you kind of do your homework and you work through these. Alright, I'm going to flip it up and explain more detail here. Oh. Let's do this. Alright, here we go. Evaluating, yep, that's not what I want. Sorry, here we go. Concept 3. Describing end behavior. Alright. So, it says describe the end behavior of the graph. Evaluate f of x equals negative 0.5 x to the 4th power plus 2.5 x squared plus x minus 1. Alright, first things first, I want to identify my degree. My degree is 4. Second thing I want to identify is my lead coefficient, and specifically the sign, but negative 0.5. Alright, what I'm going to take from that again is this. The degree is even, and the lead coefficient is negative. Even negative is really what I really need from that equation. Now, to describe the end behavior, it's always going to go left and right. What's going to change is going up or down. Okay, so here's how I go about this. I write it like this. F of x approaches blank, because that's going to change, as x approaches negative infinity. What's that approaches negative infinity mean? It goes to the left. Okay. And then also, f of x approaches blank, that's going to change, as x approaches positive infinity. That's going to the right. Okay. Shoot. There we go. Alright. This is happening every single time. Alright? These two parts are going to change. Is it going up or down? Alright? That's what's happening. But it's always going to the left and always going to the right. I can't believe I did that. Always going to the right. Okay? Alright, so now what's happening here? Even negative. Well, what is negative telling us? It's going down. Right? And even tells us it's happening with both of them. So it is down, down. Okay. Now what I need to do is finish this, and I'm going to just use a different color just so you know this is the part that changes. Well, down is just negative infinity. So now it's really read like this. F of x approaches negative infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. Even negative. If I flip it over, even negative. Down, down. X approaches negative infinity as x approaches negative infinity. F of x approaches negative infinity as x approaches positive infinity. I know that's really small for you to read, but you can check right there on your own. Okay, that's what's happening. I'm going to walk you through this next one. If you want to pause and try on your own, perfect, go for it, but I'm actually going to do it for you. So here we go. Same idea. Degree is what? Well, it is 3. Lead coefficient is negative 0.3. What do I need from that? Well, the degree is odd. The lead coefficient is negative. Odd, negative is what I want. Again, I write it like this. F of x approaches blank as x approaches negative infinity, or goes to the left. And f of x approaches what? As f of x approaches positive infinity, or goes to the right. I like arrows. What's happening there? So it just makes a little more sense, I think, to recognize. Alright, odd is going to tell me that it's going to start and finish in different spots. Negative tells me it's going to start up and then end up down, right? So if I start up, that really means I have positive infinity, and if it ends down, at negative infinity. Okay, and again, I'll draw the arrows here so you can take a look. But it should go starting up, ending down with odd, negative. That's probably going to take a little practice, you guys, but we have more practice right here. So as I go on to graphing, we are going to need that. Okay? Again, what you want to do is probably take a little extra time to always refer back to this here, and this is our chart that we can always look at. Alright guys, I'm going to stop this video and go on to the next one.